written questions, you were asked the same problem, but for the programming part, it doesn't say you cannot use loops, so you are free to use loops or not, and we can solve it both ways. What I will do is first work in the command window to show you what I get. So for n equals 10, or for n equals to any number, we need to be able to generate this series. So this is x minus 1 to the power 1 divided by 1. So it may be easier if you write explicitly. Divided by 1. Okay. So we are going to generate a vector that contains these elements. Let's first create a vector that contains x minus 1s to the power 1 all the way to n. Actually, let's separate these into several parts. So x minus 1, and I have to give what x is. Let's give an example, x equals 5. Okay? So x minus 1 gives you just that 4. If you take x minus 1 dot to the power 1 all the way to n, this will give you x minus 1 to the power 1, x minus 1 to the power 2, to the power 3, all the way to n. So I'm getting, as a result, these numbers, which are this portion right here, x minus 1 to the 1, x minus 2 to the 2, and so on. Okay, so I took care of that part. To take care of the bottom parts, you just do 1 colon n. So that's easy. That's another vector. Now, the trickier part is figuring out these plus 1s and minus 1s. So you need to create a vector that contains a plus 1, minus 1, plus 1, minus 1, all the way to however n's you have. And you are told that n can be odd or even. Okay? But in the written part, you are told that n is an even number, which is easier. For programming, there's a difference. Okay, so what we'll do is, let me solve for the written part first, where we are guaranteed that n is an even number. So if I take this vector 1, minus 1, and then replicate it, 1, comma, n divided by 2 times, I'll get the vector I want. I'll get the factors that I can multiply into the other vectors. All right, so I have 3 vectors that I constructed for you. One is this one, x minus 1 to the power 1, x minus 2 to the power 2, all the way to x minus n to the power n. That's one of my vectors. And to do that, I just did x minus 1 dot power 1 colon n. So that gave me that expression, that vector. The second one was just numbers 1, 2, all the way to n. The third one is these 1 minus 1s, and you get that. And if n is an even, the last one will always be minus 1. So now I need to combine these 3 vectors and get the actual terms that I need to add up. So I will take, let me call this A, this one B, this one C. If I multiply A with C, but I need to use dot multiply, I'll get plus x minus 1 to the power 1 minus x minus 2 to the power 2 plus x minus 3 to the power 3 minus x minus 3 to the power 3 and so on. Sorry, plus. So you'll switch plus and minus. Yes, question? So for the RapMath, let's go back to RapMath. Actually, I lost it. I'll go back to it in a minute, okay? So I have these three vectors that have the same size. And then I will divide by b, but I need to do dot divide. And now I have those individual terms, x minus 1 to the power 1 divided by 1, minus x minus 2 to the power 2 divided by 2, and so on, okay? So you construct these individual three individual vectors, and you perform vector operations, and as a result, you are creating a vector that contains these terms. Okay? So as a vector. So they are separate, but we need to add them up. So you will just do sum. Sum function will take a vector and just add up the terms and give you a single number. And that will be the answer. Okay? All right, so there was a question, why did I do RapMath and divide by 2? And that's because the thing I'm replicating contains two elements, two numbers. So if n is 10, you need to replicate it 5 times. All right, so let me give you a smaller n. If n is 4, you replicate it twice. So 1 minus 1, 1 minus 1, okay? All right. So let's go back here, and we already have the answer, but let me go over this answer for you. So in the answer for the written part, n is not guaranteed to be an even number, so you need to construct that vector 1 minus 1, 1 minus 1 in a different way. And that different way is the following. First, I construct a vector of 1s, and then I replace every other element with minus 1. Okay? And this will work regardless of whether n is an odd number or an even number. The reason for the written part, I told you n, you should assume n is an even number, was that question also asks you to solve that problem in two statements. Yes?
So I is like positive 1, negative 1, 1.
Yes. So if n is an even number, the last element is going to be minus 1. If n is odd, the last element will be plus 1. All right? So this is just a different way of, instead of RapMath, you use this other method to create a vector of plus 1s, minus 1s repeating. Okay? All right. So what I do is I take x minus 1 to the power 1 colon n. So this is one of the vectors. This is the other one. And this one, as a result, will give you a single vector. And then you divide by the numbers 1 colon n. And you multiply it with plus 1s, minus 1s. And each of these operations are element-wise operations, so you always have the same size of the vector that you generate. And you take the vector that you generated, give it to the sum function, so it adds all of those terms up and gives you the answer. All right? Okay. So to write this in a for loop, what you would say, for instance, for I equals 1 to n, the only thing that will change between different iterations is whether I is odd or even. For odd i's, you will multiply it with plus 1. For even i's, you will multiply it with minus 1. Sorry. For even i's, you will multiply it with -1. For odd i's, you will multiply it with 1. So let me solve it this way using a for loop. For I equals 1 to 10, if I equals, if mod I comma 2 equals 1, that means it's an odd number. I'll add into s equals s plus something. Else, I'll subtract from s equals s minus something. And that something is going to be the same regardless of whether I is odd or even. So it's going to be I minus 1 to the power I divided by I. I minus 1 to the power I divided by I. So here I'm not really doing element-wise operations because in the for loop, I will always be a single number, and I can just use multiply and divide because it's a single number, it's not a vector of numbers. So these, as the for loop iterates, I will be 1, I will be 2, and so on. You are generating each of the terms and adding them up into a total variable s. And s will be the output that I should really change with y. Okay? So this is the other solution. Questions? All right. I like this one better. If you can avoid for loops, it's just cleaner. All right, in the next problem, we will solve gene ID to symbol. That was one of your homeworks. And you can see that these problems sort of follow the written problems. One of the written problems was to find the positions of commas and then take the portion in between. And in this programming problem, you need to find the locations of tab characters and then extract the portion that's in between. So let's take a look at this example file. All right, let me just do this. Edit gene. .txt. Okay, so this is the file, and they are separated by tabs. So if you move your cursor using the arrow key, you see it's jumping, right? So it's not a space character, it's a tab character. Your MATLAB editor is aligning where the tab characters are, but if you use your cursor to move to the right and left, you see it's jumping on that space, which means that there's a tab character instead of a space character there. All right, so let me say that again. When you are browsing in this file using the editor, so I'm moving to the right 1, 2, 3, 4, 5. So it jumped more than one space. That indicates that this is not really a space character, that big key on your keyboard. It's not that one. It's the tab character on your keyboard. It's not really equivalent to 5 spaces. It depends on what your editor is set to show. And you can change that on your MATLAB preferences. So if you go to preferences, editor, tab, you can tell MATLAB to show each tab to be 10 spaces. So whatever you visually prefer, you can show the tabs that way. Okay. All right, so what we'll do is read this file line by line. And for each line, we will check whether the ID of the gene matches the one that's requested from that function. And if it does, then we will return the name from the same row. Okay. Should I start from scratch, or should I just show you the solution and go over that? Start from scratch? Okay. Gene ID to symbol. I think I have the solution here. .n. All right, so we are given the file, and we will assume the file exists in the current directory. The function does not ask you to take the file name as input, so we'll just hard code it. It's good to store it in a variable. We'll open the file using fopen, and with the parameter r to tell MATLAB that we are intending to read the file, not write into it. And then while not end the file, so long as we are not at the end of the file, we'll read the next line. Let's use fgetLine function to read it. So in each iteration of this while loop, we are reading a single line from the file. That after this line is executed, the line variable is going to be a single string containing that particular line that we are at. So let me put a breakpoint there, and it's also will make your job easier if you give some examples. So here, if not exist ID. So I'm doing this so I don't have to go into the command window to test this function. I can just hit F5 to run it. So if ID is not provided, I'll just use this default value. I'm hitting F5, and it'll stop where I ask it to stop on that breakpoint. So F contains 3, which tells me that the file was successfully opened. I'm going to hit F10 and go back to the command window and type line. That's the line that was read from the file. Hit F10 again, goes back to the top, read the next line. Let's look at the contents. It's that one, all right? So when I'm reading each line, I need to extract the portions that I need. And the portions that I need are the second one and the third element. And these elements, these tokens, are separated by tab characters. So if I say line equal tab, and to get a tab, you can use sprintf function. So that's how I will get the numerical value of the tab character. So I get a logical vector. Let me shorten line for you so it fits on the screen. 1 to 20. All right, so I get a logical vector of zeros and ones. There will be a 1 wherever there's a tab character in line. Let me store that in locations and also wrap it with find. So instead of a logical vector, I will get a numerical vector of positions of the tab characters. So there's a tab in the second character of line, in the 10th character of line, and in the 19th character of line. If I show you line again, so what I need is what's between the first and the second tab characters. That'll give me the ID of that particular line. And the second and the third tab character, that range of characters is going to give me the name, the symbol of the gene. So locations 1 plus 1. So the location of the first tab, 1 past that. all the way to location of the second tab, one before that. So this is going to be it's going to be numbers, because I'm generating a range of numbers using the colon operator. But those numbers correspond to locations that are between the first tab and the second tab. So I can use this to select from the line string. Okay? All right. So this is how I identify the ID of that line. I believe the numbers, the IDs are given as integers. So let's convert it to a string here, num to str ID. Or you could do it the other way around, which let's do it that way. So we'll say if str to double, we take that string that we extracted from line and say equal ID. If the ID we extract from the line that we read last and compare it to the ID requested from the function, only if they match, then we will examine the symbol, the gene name for that line. Okay? All right, so the gene name is going to be exactly the same idea, but now instead of extracting between the first and second tabs, we'll extract between second and the third tabs and store that substring between those two tabs in the output variable sim. And you can let this function run until the end of the file. But if you are satisfied with the first hit, you can also say return. The caveat with return is that before you return, you also need to close the file. But if you don't do it here, you can just do it here, fclose, f, and let's break here to be more efficient. So once you find a matching line, you can break out of the loop so you're not really reading the rest of the file redundantly. Okay? So this the solution, let's save it, and fclose all will close all the open file identifiers, because while debugging, I opened the file, but I did not close it. This is one way of closing all the files that you have open in MATLAB. And let's copy and paste this example, and hopefully it will give us the correct answer and not embarrassment. Okay, we get an undefined thing, so we forgot to do that here. Let's repeat it. Attempted to access logs1. Okay. So you see you are getting these errors, but since you have a loop, you don't really know at which iteration it happens. The one way of finding the error is to put the breakpoint and then repeat until you hit the error, right? But whenever you hit the error, MATLAB takes you out of the function. One thing that you can ask MATLAB to do is to stop the execution right there, so you can examine the contents of the variables. And to do that, you need to say db stop error. And it's enough for you to say this once when MATLAB is open, and it'll remember this option until you close and restart MATLAB. All right, so now whenever an error is to happen, sorry, I should really remove this breakpoint. Let's repeat. So whenever an error is to happen, MATLAB will again print out the error message, but it will stop in that file on that line where the error happened. It doesn't get out of the execution. All right, so now I can examine and see what went wrong. If you look at the line, let's look at logs. It's an empty empty vector. All right. So look at the line. It's that first line of the file. All right. So it says format, and then there's really no tabs here. That's what's causing the problems, because the locations is empty vector. So we matched against the tab character and found all the locations that had a tab, and we ended up with an empty vector. So we need to safeguard against this case. And one way to safeguard it is to say if number of locations is less than 3, because we will need at least 3 of them to identify the gene name, then continue. Go on and read the next line. If you're not comfortable with the continue statement, you can combine this expression down here and say if the number of locations is greater than or equal to 3 and the ID that I'm extracting is the same as the ID requested from the function. Okay, so both these will work. If you take this numel looks greater than 3 and put it at the end of this line, it will not work because you are using locations 1, and if locations is empty, it will give you an error. So whenever you end things, MATLAB evaluates them in order. It'll look at the first term of the ending. If it is true, it'll move on to the next one. If it finds a false, it won't bother evaluating the rest. That's why when I say numel looks greater than or equal to 3, if this portion is true, and only if it is true, it'll move on to evaluating the second part. So the second part is only evaluated if I have enough locations, enough numbers in the locations vector. If this is false, then we already know that false and anything else will be false. So MATLAB will not bother evaluating the rest. So we are skipping that line, moving back to the while loop, and reading the next line. All right. So let's rerun this. Hopefully now it will work. Okay, so you get the answer. All right. And you should test for all such examples before you submit it to the programming bank, because you want to make sure that it's easier to test here before you submit. Okay, so test in your MATLAB first. If it works, then submit it. All right, the last problem that we will solve in hopefully less than 20 minutes is the HIV simulate problem that was, again, a homework problem. Should I start from scratch or go over the solution? Scratch, okay. Question? The logs was this. So I'm comparing the line, which is a string, and I'm saying equal, equal. This sprintf tab is the tab character, which you don't see because it's just a white space shown as white space. But if you convert it to a double, it's a number, the number 9. So if you know, if you've memorized the character number for tab, you could just say 9. Yeah, logs equals 9. Okay. Oh. I have to generate a fake string here because line is a MATLAB function, and we are out of context now. I no longer have the line variable. That's why I had that plot shown. Okay, so we are taking line, which is this string, and the backslash t's correspond to a tab character if you use the sprintf function or fprintf function. So the difference between fprintf and sprintf is that fprintf shows the result on the screen. sprintf returns the result so you can store it in a variable. So you check which elements of line equals 9 or instead of 9, you can also use sprintf \t. So this is how I don't memorize a tab character, but I need to know that it's a \t. And you get the 7th character and the 13th character of the line equal to tab character. Yes?
So if you were looking for something split in, did you just look at the ASCII table?
You could use, I wouldn't recommend using the ASCII table. It's better to use the actual character or use sprintf to generate it.
So how are they, is there some, like a list you could look at?
You should never need to look at, you mean these backslashes?
Yeah.
So you need to know \n, you need to know \d, and that's all backslashes you need to know.
So backslash and
The new line. There's also \r actually, which is also a new line. Okay? All right. So \r is a new line, \n is the more common new line, \d is the tab character. Okay? All right. Let's close that. And let's start HIV simulate. Let's see, we are taking UIV delta. Let's just copy and paste this. We are not returning thing. Are we returning anything? Yes, we are returning the resulting matrix. Let's call that out. Okay, so we have these 3 equations that gives us the difference between time steps. And we will construct a 4-column matrix that contains time and UIV. And we will use these parameters. Let me just copy and paste these parameters into MATLAB. Alpha equals 10. Sorry, that's sigma equals 10. Sigma equals 10, alpha equals 0.02. If I make an error, please try to warn me. U max equals 1500. Beta equals 0.24. Gamma equals 2.4. K equals 0.0027. And N equals 10. Okay. So we will start with an initial concentration, which is given to us in this as input. So I'll just copy these, and to speed up testing this function, I will say if not exist, you then use some default values. U equals that, I equals that, B equals that. And when you are done with finishing up this function, you can always delete this entire portion, okay? Unless the question is asking you to support some default values. Delta T equals that, and T equals that. Okay. All right, so we will construct a matrix out that contains the time step U, I, V. So initial time step is 0, and initial concentrations are U, I, V given to us in the input. Then we will write a for loop for I equals up to T days 1 to T. Actually, let's do this. Okay. There's one caveat that you need to worry about when the number of outs is going to be is starting from 0. So just to simplify things, let's start this from 1 and let's start this from 2. Okay. You can always go all the way to t plus 1. So it's the same thing. All right. It's something I'm letting you to decide if you want to do it that way. All right, so we've already stored the first time point values, and then now we need to calculate values for the second time point all the way to time point t. So how do we do that? We will use these difference equations. So du tells you how much u changes at each time point. du equals f of u, and we will replace that f of u with something else just in a minute. K times v times u, and it says f of u equals that. So you can either define a subfunction that has f of u, or let's just write it down in here. And let's introduce a new variable. Fu equals sigma minus alpha times u plus p times u times 1 minus u divided by u max. Okay? And I will replace this with fu. Or instead of introducing a new variable fu, you can just cut and paste this in here. It'll be the same thing. So let's just do it in 2 steps. So it looks similar to the equations given on the question. And then di equals minus beta times I plus k times v times u. dv equals minus gamma times v plus n times beta times I. Okay, so now I calculated each of the difference terms, and I need to add up these difference terms to the previous values. So du tells you how much u needs to change from time point 1 to time point 2, or from time point 2 to time point 3. I already have time point 1. I will just add du to it to get the value for time point 2. Or at any iteration I will use the previous values of u and the previous values uiv to calculate the next values. All right, so let's say out I comma colon. So I'm going to insert as the next row of out the values of t, I, tu, iv. So u equals u plus du, I equals I plus di, v equals v plus dv. Those are the new values of uiv. And as the new row of out matrix, I will have the I time point and the new values of uiv. Okay? Good? All right. So let's, and as you are working on this problem, I would run it step by step. So after you make a major change, a major addition, run the file and make sure you get what you expect. So before we go into plotting, let's make sure that we get the out matrix. And what I'll do is copy this, paste it in there, and I get something. Oh, I'm actually running the solution that in the same directory. So I get some errors that are, I get another numbers, okay, which is not desirable. All right, so that means I'm doing something wrong. So let's go back in here and look at it step by step and see where another number occurs. So F10, FU is 724, DU is minus 86, DI is 570, DV is 0. UIV, the next 214, 370, 1000. And out is that. Okay? Alright, so far so good. Let's keep going. Okay, yes. Good point. But let me keep going. So you see the numbers are going really large, right? And if you look at the figure, those are also going large, but individual time steps take you at a smaller increment. So instead of doing du equals minus 21, we need to use the delta t to multiply it into a smaller number. Okay? So this is du is going to be how much it would change in a whole day, but we need to simulate in delta t time points, and delta t can be smaller than 1 day. All right, so we need to, let's say, calculate it in 0.1 days at each time step. So for each of these terms, we'll multiply the difference with delta t. Or let's do it here. Delta t. Same thing with this. Delta t times delta t. All right, so we saved it. Let's do it again. And we get more reasonable numbers. At least we get not other numbers. And now we can try to plot it. Let's go in here. So to plot it, we will have 3 lines. If you look at the documentation for the plot function, you can actually plot those 3 lines with a single call to the plot function. So if you say plot something, let's say A, B, C, D, E, comma, F. So this is equivalent to plotting A and B, and then plotting B and C, and then separately plotting E and F as 3 different lines. Okay. If you want to have the same effect with different plot calls, then you need to plot A and B, and then hold on, and then plot C and D, and then hold on again. Actually, once you hold on, you don't need to hold on again. And then plot E and F, and then hold off. Okay, so hold on makes sure that when you call the plot function, it doesn't wipe out the previous plotting that you did. Otherwise, if you don't have this hold on here, what will happen is you are plotting A versus B, so you got a graph, and then the next time you call the plot function here, that nice graph you have will be wiped clean, and C versus D will be plotted. So you are holding on and telling MATLAB to not wipe out what you have on that plot. All right. But let's use the first method where we will plot out first column against out second column, out first column against out third column, out first column against out fourth column. All right, let's hit F5 and we get that. Okay. So it follows the same graph with a different time scale, I believe. Delta t is 0.1. Let me change delta t. So let's look at the definition of t. So the definition of t says up to t days, but what I did here was up to t time points. So if delta t is half a day, and you want to simulate up to 10 days, what I'm doing here, I'm actually simulating up to 5 days, because each iteration would correspond to half a day, and if you iterate 10 times, it would be 5 days. So I'm not using the capital T parameter properly. What I really need to do is say capital T divided by delta T. So that many days. Sorry, that many iterations. So capital T is the number of days, delta T is how many days each iteration should take. If you divide them together, it will give you the number of iterations you need to perform. That's why my plot is sort of, it's not really going up to the 100 days, it's going up to 10 days. We do it again. It's asking that T divided by delta D should be, let's make sure it's an integer. Let's take the ceiling and run it again, and you get that. Okay? All right. Questions? Okay, it took us exactly, actually less than 20 minutes if there was also a question. All right, good. So that's the end of the